Hello, we are in Chapter 7, Section 7.1, Composing Functions. In this video, we are going to go over that concept, what a composition of functions is. You are probably familiar with the concept of doing the laundry that consists, believe it or not, of two machines, the washer and the dryer. And what we do is we take a basket of empty clothes, we put those clothes in the washer transforms them, washes them, and the output of it is wet clothes that we put in the dryer. And then, once the dryer transforms them, dries them, we get nice and clean, dry clothes. Think about it mathematically. Let X represent the dirty clothes, the input that we put in the washer. The washer is a function that transforms its input into washed. So we throw the X into the washer that we called f of x, and it transforms it to its value f of x. Let's call the dryer now G, and we are throwing the output of the washer that is f of x into G to obtain the final output after G transforms it, G of f of x. Now, as I mentioned earlier, it's doing the laundry, which to some is just a single process. And mathematically, we can also think about this composition as a single process. We start with x, and then we transform it using the function g composed with f, that is denoted as g little circle f. This notation indicates that we are applying those functions in that order. F is applied first to the input x, and then it's followed by g once the output f of x is computed. We need to use parentheses here to denote that label because it's more than just single character, and that's the new function from x to g composed with f of x. Let's have a look at an example. Given those two functions, we are to find the composition f composed with g of 3. So we're looking at that composition function, but now g is the first function applied, so we will be first computing g of 3. So labels don't matter, what matters is which function is applied first, but we also need to understand how those functions affect the inputs. And what g does is to double the input and add 1, while what f does is to square the input and take away 3. So our first task is to evaluate g of 3. So we are throwing 3 into g transforms it, and we get 2 times 3 plus 1, which is 7. So g of 3 is 7, and now we remember that we are really computing that composition, so we have to apply f on top of g. So f on top of g of 3, that means f on top of 7. 7 is thrown into the function f. And f of 7 is 7 squared minus 3. So let's rewrite it here and compute it. 7 squared is 49, so we have 49 minus 3, and that is 46. And that will be the final answer for this problem.